So today we're going to roll with lesson 3.6. Lesson 3.6 has to do with graphing inequalities with polynomials. So the first one is going to be odd just because we're usually never given the equation in this form. It's in factored form, which is unusual, but it actually is kind of nice just to get us started. We know that this is greater than equal to 0. Greater than 0. Okay, so when we're going to graph a polynomial, first of all, we have to find out what my critical points are. The critical points are going to be my zeros. In this case, I know my 0 is going to be 5. Okay, I also know my 0 is going to be -6. So what happens when we talk about this is if we look at a number line, what happens is it's going to create intervals. I'm going to have if I put -6 in the number line and 5 over here. Again, it's nothing for spatial reasoning. It's just to get us an idea of what intervals we have. There's an interval that's created that goes from -infinity to -6. There's another interval here that goes from -6 to 5. And there's a third interval up here that goes from 5 to infinity. Anyway, so of this, it could be 1, it could be 2, and of those intervals could be solutions for this polynomial. So now we have to figure out which ones are the solutions to the polynomial. And that's when we're going to go back to a sign test, which we did in our last section. So what we're going to do is we're going to pick a number that's between -infinity and -6. So I'm going to roll with -10. Okay, and remember we're plugging it into x minus 5 times x plus 6. So when I put a -10 into that, I get a -15. I can put a -10 into this term, I get a -4. So that means if I'm multiplying these together, I'm going to take a negative number times a negative number, and I'm going to get a positive number. Okay, and last time we used that to know where my graph went. Now today we're going to use it to figure out what my solution is. Okay, I'm going to go ahead and do all of them first, and then we'll come back. So I need to enter some number between -6 and 5. That would be 0. It's always the easiest one. That gives me a -5 and a +6, which gives me a negative when I take a negative times a positive. And then lastly, we can use +10, because that's going to give me a +5 and a +16 for a positive number. Okay? And so what happens is, let's go back to my original polynomial. This product has to be greater than 0. And the types of numbers that are greater than 0 are positive numbers. And I got positive numbers from -10. And when I tested +10. So that means that my solution is going to be -infinity to -6, and I'm going to union that with 5 to infinity. Okay, so we used a sign test to figure out the solution there. Here in a second, I'll come back and I'll show you the other method that we can use, but I'm going to do all the sign tests first, and then we'll come back and show you the other way. Okay. Number 2 is more typical looking. X squared minus 7x plus 10. This is also going to be greater than 0. Okay, so we're going to factor this. This is going to factor factors of 10 that add to give me 7 are going to be a -2 and a -5. So we get critical values of 2 and 5. So again, if I just draw this out on the number line to help me, here is 2, here is 5. I've got an interval that goes from -infinity to 2. I've got another interval that goes from 2 to 5. And I've got a third interval that goes from 5 to infinity. And again, it's figuring out which of those intervals give me true answers. Okay? Meaning I'm going to grab a number out of this interval. I am going to grab 0. We're going to do a sign test on it. So remember, we're testing into x minus 2 and x minus 5. So when I put 0 in there, I get a -2, I get a -5. 2 negatives make a positive. And I want positive numbers. So that means that this one is good. Between 2 and 5 is 4. 4 minus 2 is a +2. 4 minus 5 is a -1. But when I take a positive times a negative, I get a negative. And I need positive numbers, so this is not going to work. And when I come back for here, 5 to infinity, 10 is in that one. So 10 minus 2 is a +8. 10 minus 5 is a +5. So 2 positives give me a positive, and that's what I need. So that means that my solution is going to go from -infinity to 2. We're going to union that with 5 to infinity. Okay? That's what our sign test is and what it's going to look like. Number 3 is x squared plus 4x plus 3 is greater than or equal to 0. So this one has a little bit different look to it. And it's not really a different look, huge different look. It's just the fact that this one has the equal to sign in there as well. So that's its only really difference. So we're going to factor that. Factors of 3 are going to be 3 and 1 because they need to add to 4. So we get -3 and -1. So here's -3, here's -1. So that means my intervals are going to be -infinity to -3. But now we're going to have a bracket in there. We're going to bracket this from -3 to -1. So here's the only difference in this. So there's -1 to infinity. So and that's a parenthesis. So again, the only difference between this problem and the last problem is we had to use brackets because of the equals to sign. But we're still going to sign test the same numbers. So between -infinity and -3 is -10. I'm going to come back over here instead of rewriting it. So -10 plus 3 is a -7. -10 plus 1 is a -9. Two negatives make a positive, which is what I want. Testing -2 in this one. -2 plus 3 is a +1. -2 plus 1 is a -1. That gives me a negative. Not what I wanted. And then lastly, we're going to test 0, which is going to give me a +3. It's going to give me a +1 for a positive. So that one also checks out. So again, not a whole lot of uniqueness to it. It's going to be from -infinity to -3. And we're going to union that with -1 to infinity. Okay. We'll come back and look, and we'll look at this in a second. What do I want to do here? We'll do number 4 just because it's less than. You'll figure out when we're talking about a quadratic, you'll figure out a pattern here shortly. But we have 5x squared. We have +13x. We have a -6, and this is all less than 0. This one is going to test our factoring ability a little bit just because it's got that 5 out in front here, so I know it has to be 5x and x. I have to end up with 13x in the middle. I have a -6 here, so that means my signs have to be different. Whether it's 2 and 3, I think it's going to be 2 and 3. I'm going to go with here. I'm going to put the 3 here, and that way I can get 15. I'm going to put the -2 here, and that way I get the -2x. So that means I can, that's factored. All right, I'm going to end up with a 13x in the middle. So I add the 2 over and divide by 5. I subtract the 3 over. So this one has multiple things to it. It also has the fractional roots, but it all runs the same exact way. If we need to write it on a number line, we could. But anyway, we're going to start out with -infinity. -3 is my next number. We're going to hit parentheses this time. Now it's going to go from -3 to 2/5. Then we're going to have a third interval that goes from 2/5 to infinity. Okay? So this is all the same exact stuff. We're testing numbers again, so we're going to test that -4. So a -4 is going to give me a -20, -22, so that's a negative. -4 is going to give me a negatives. Two negatives make a positive, but in this case, a positive is not what I wanted. We want it to be less than 0, which is negative numbers, so that's what I want here. Between, whoop, that should have been a -3. How about that? Between -3 and 2/5 is 0, so that'll be -2. This will be a +3 to give me a negative, which is what I wanted. So this time, this one checks out. And we got 2/5 to infinity, so 10 works there. So that will give me a positive and a positive for a positive, not what I wanted. So again, this is just going to be one interval from -3 to 2/5. Okay. So again, there isn't anything rocket science-y to this. If I can remember my passcode. All right, I'm ready to move on to something, a cubic one, if we ever get there. That's another quadratic. 5 is another quadratic. I'm going to move past the quadratics. That one, the only additional step is we need to subtract the 50. We need to, let's see here, I'll start it. We have 3x squared plus 4x is less than 15. Well, now we need to subtract over the 15 in order to get that in a factored form, to get ready to factor. But now it's going to work exactly the same. I'm going to move on because I don't think I need to do any more quadratics. And I'll come back. We'll talk about the other way to look at these in just a second. I will talk about number 6 for a second. Number 6 is a little bit funny. No, 6 is not funny. It's when we get into double roots that it's funny. Anyway, this is going to factor like normal. I'll even factor this one for you since we're staring at it. We're going to plot an x to leave me with 5x plus 8. And the rest of that's going to work exactly the same as the other one just did. All right, 7. I'm trying to get to something with a higher degree than 2. So that's actually when it gets fun. There we go. X cubed plus 6x squared minus x minus 6 is greater than or equal to 0. Okay, so it has 4 terms. So again, it's going to be predicated on our ability to factor. We're going to do some grouping here. So we have x squared. That leaves me with x plus 6. We take out a negative 1. That also leaves me with an x plus 6. And so we take away the x plus 6, which leaves me with x squared minus 1. And so, again, continuing to factor this all the way out because I can. This is what we're looking at. Okay? So now we have negative 6, negative 1, and positive 1. So we have to understand here that we've thrown in another 0, another critical value. Negative 6, negative 1, and 1. So this adds another interval. We have negative infinity to negative 6, so we're going to block that off. Then we're going to go from negative 6 to negative 1, and then we're going to go from negative 1 to 1, and then we're going to go from 1 to infinity. So again, now we have 4 intervals to check, okay? So that increased the amount of sign tests that we have to do, and when we roll with that. Here we go. From negative infinity to negative 6, we're testing here. So I'm going to test something like a negative 10. So that's going to give me a negative number there. It's going to give me a negative number there. It's going to give me a negative there. So if I multiply 3 negatives, I'm going to get a negative. Okay, because this is greater than, it still works the same. I want positive, so that means that interval is not part of my solution set. Okay, between negative 6 and negative 1 is negative 5. So that's going to give me a positive here, but it's going to give me a negative on this one and a negative on that one. So that means it's going to be positive, which is what I want. So that's part of my solution set. 0 is between negative 1 and 1. So again, we're going to start testing on 0. So 0 plus 6 is 6. 0 plus 1 is 1. 0 minus 1 is a negative 1. So this is going to give me a negative, not what I wanted. And lastly, we're going to test 1 to infinity. So that'll be 10. That'll give me a 16. This will give me an 11. And this will give me a 9. So that means we have positives in the end, which is what I want. So again, this is a multiple interval answer. It's going to go from negative 6 to negative 1. We're going to union that with, needing a bracket again, 1 to infinity. Okay, so that's where we're going. And there's actually, again, if you actually are pretty quick at sketching a graph, we can actually do this faster without having to do a sign test. But we're going to see what 8 holds first. Unfortunately, there's only one. So here we go. Now let's roll back and we're gonna look at the other method to do this at, because 8 jumps us into a rational one, and I don't want to do the rational because I in reality, well, I'll do it both ways when I get there. But here we go. Let's look at a different way to do this. We'll go back and do a couple more. But we decided we had critical values at negative 6, at negative 1, and 1. So what ends up happening is we're actually going to graph this. Okay. So this is going to go back to stuff before we did on spring break. We have to talk about end behavior. Okay, this is a review of end behavior. The sign of my polynomial, the leading coefficient, has control of my right hand, so I know my right hand is up. I know that my left hand, because this is an odd function, my left hand is going to be down. And I know that all 3 of these roots are single roots, so I know it has to pass through, and pass through. It had a y-intercept down here at negative 6. That was irrelevant, because here's what's happening. I need to look at what part of this graph is above 0, which is the x-axis. And if I look at my graph from -6 to -1, it is above the x-axis, and that's where this interval came from. If I look over here from 1 to infinity, having trouble with that word today, it is also above the x-axis, which is this interval here. So we could actually look at the sketch of the polynomial and get to that answer a little bit faster than just doing a sign test. Okay? So I'm going to pull this back over here, and we're going to look at this one just to see what we could have done with it. Okay? We decided, if we're going to sketch this real fast, we had a 2/5 critical value there. -3 was a critical value there. We know that my right hand goes up because it's positive. This is squared, so it's positive. Actually, all of these are going to be parabolas, and so this is the shape of my parabola. Okay? All of these are parabolas. Okay? Now, what part of the parabola did we want? Well, we wanted the part of the parabola that was below 0, which is going to be underneath the x-axis. Well, it was underneath the x-axis from -3 over to 2/5. So this was the part that was underneath the x-axis, which is the same exact interval we have from -3 over to 2/5. So again, a quick sketch can get you there actually much faster than doing a sign test. The sign test is pretty straightforward. We can't botch that too bad. All right, so let's look at 8. And my iPad tends to be turning off on me, so let's see if we can get this back. So it is x plus 4 over x plus 9 is greater than 0. I will do this both ways, okay? But here we have to pay attention to what we're doing. I mean, this one isn't so bad. It's when we get the equal to sign in there, that's when things kick up a notch. We got to pay attention to one other thing. But my critical values still remain the same. I am going to have one at -4 and another one down here at -9. It's the values that cause that 0 to happen. So if I'm doing my sign test, I can still do my sign test. It's going to go from -infinity to -9. It's going to go from -9 to -4, and it's going to go from -4 to infinity. And I can still test this the exact same way, except now we have a quotient to do instead of a product. So a number that -10 is in this interval. -10 plus 4 is a -6. -10 plus 9 is a -1. Two negatives make a positive, and I wanted positive, so that checks out. -5 is in this interval. So that's going to give me a -1 on the top. It's going to give me a +4 on the bottom, but that's negative, not what I wanted. And then lastly, 0 is going to be in this interval. That's going to give me a positive and a positive, which is a positive, which is what I wanted. So that checks out as well. So this is going to go from -infinity to -9. We're going to union that with -4 to infinity. If we're going to, again, just reviewing of my sketching of a rational function, this is my vertical asymptote at -9. That's going to be my vertical asymptote. Okay? This is going to be my horizontal asymptote. It's going to be, since this is a 1 and this is a 1, my horizontal asymptote is going to be that ratio of 1 over 1. So I have a horizontal asymptote going through there. Okay? My numerator happens to be my x-intercept. It's over here at 1, 2, 3, and 4. So at -4. Okay? And my ratio of constants is actually my y-intercept, which is there. So if we look at this graph, since there's no x-intercepts over here, I know it has to exist up here. And I know because of that intercept there and this intercept here, it looks like that. So again, it wasn't necessarily a quick sketch, but we have sketched the graph of that rational function. Now, what part of this function is above 0? Well, this entire chunk is above 0. Well, this is -infinity to -9. We already got that guy in there. And then from here, from -4, this direction, it is above the x-axis. So that was -4 to infinity. So again, sign test or graphing, you have to figure out which method you want to use to do that with. Okay? X plus 1 over x plus 2 is less than 0. So this one goes the other way. Lose my train of thought here. -1 is a critical value and -2 is a critical value. So we could sign test this. Okay. However, I think I'm just going to sketch the graph of it because I'm just in the graph sketching mood. Okay. -2 is going to be my vertical asymptote. Again, it's that 0 that causes my numerator to go to 0. These are both 1s, so that means this ratio here, these are going to be pretty straightforward to graph. So we have a horizontal asymptote at 1, and then we set at -1, we have another one. This ratio of constants is going to be here, so that means my graph looks something like that. And in reality, you're going to have your calculator. You could just type this into y equals in your calculator and look at the graph as well. What was this? X plus 1 over x plus 2. Which is the same graph as we just came across. We could hit trace, but we see at -1, -2, there's my vertical asymptote. This part right here is above 0, so that's why my answer is going to be -infinity to -2. We're going to union that with, because from here to here, we're looking at my graph. From -1 on, it's above the x-axis, so actually you really couldn't see that. Washed out so easy. From -1 to infinity. Give me another one to test that. Okay. 10 is the same way. So these are all repeat problems. I've given you some stuff to go off of, so I'll make this one short. I don't know where we at on this, the length of this video. Well, anyway, we're gonna cut it off. So, all right, one more video to go, and oh, there it is, 22. I guess it helps.